Welcome to Thriving Academy. In today's class, we will be looking at derivation of the continuity equation for radial flow using this diagram. And remember that what we did in the last class, we did derivation of continuity equation for a rectangular block. So this one is for a radial flow considering a cycle or a well. Now remember that our continuity equation, we said that the mass accumulated is equal to the mass flow in minus the mass flow out. But for radial flow, the mass flow in equation is given as 2 pi r plus the r h rho v, then at r plus the r, and the mass flow out is 2 pi r h rho v at r. Then the mass accumulated is given as this, is given by this particular equation. So our next step now is to substitute the mass flow in, the mass flow out, and the mass accumulated into this particular equation, just as we did in the rectangular block. To substitute, in place of mass flow in here, we can simply replace it by this equation. In place of mass flow out, replace it with this, and in place of mass accumulated, we are going to replace it with what? This particular equation. So let's go. We said that our mass accumulated is given by this equation. So we can simply say that mass accumulated is phi density at T plus delta T minus phi density at T divided by delta T multiplied by 2 pi r the r h. So everything here is just the mass accumulated is equal to our mass flow in. What is our mass flow in? We said our mass flow in is this equation. So it will be equal to 2 pi in bracket r plus delta r plus delta r h rho v at r plus the r. Now everything we have here is the mass flow in, then minus 2 pi. Now remember we are at mass flow out. Our mass flow out is this, which is 2 pi r h rho v at what? R. So we can simply say if we substitute the equation, we have our mass accumulated, which is this, is equal to mass in, which is this, minus mass out, which is this. Since we have this, the next step now is to expand this particular bracket. So let's do this. So let's expand. If we are to expand this will give us 2 pi. Now the first one is arrow times this will give us 2 pi r h rho v at r plus the arrow. Now this one now is just for the one with arrow. The next step is to expand using this one. So this becomes plus 2 pi. We are done with this one, which is this. This becomes delta arrow h rho v at what? Arrow plus the arrow. Then minus 2 pi arrow h rho what? V at arrow. So this we have. Now, since we have this, the next step now is to divide through by 2 pi arrow delta arrow h. Divide through by 2 pi arrow delta arrow h. That is 2 pi arrow delta arrow h. So if we are to divide through by 2 pi arrow delta arrow h. Divide this one here. Okay, this is supposed to be by delta t. Divide this one by 2 pi arrow delta arrow 2 pi arrow delta arrow h. We are going to have everything here will cancel this one. We'll be left with phi rho t plus delta t minus phi rho t divided by delta t will be equal to, if we divide through, 2 will cancel 2, pi will cancel pi, arrow will cancel arrow, then h will cancel h. We'll be left with rho v divided rho v at arrow plus the arrow divided by delta arrow will be left, delta arrow. We are done with this, plus divide this one here by 2 pi arrow delta arrow h. 2 will cancel 2, pi will cancel pi, delta arrow will cancel delta arrow, h will cancel h. We'll be left with what? Divide by arrow. So this becomes plus 2 pi plus rho v at arrow plus delta arrow divided by arrow, then plus the next step is this one here. Divide by 2 pi arrow delta arrow. 2 pi will cancel out, arrow will cancel, h will cancel. So we are going to have plus rho v at arrow divided by delta arrow. So we are going to have this. Since we have this, the next step now is to collect like terms. Collect like terms. And to collect like terms, this will give us phi rho t plus delta t minus phi rho t divided by delta t will be equal to, now if you look at this, this is divided by delta arrow, this is divided by delta arrow. So take the ones that divide by delta arrow, we are going to have, this will give us rho v. Remember, okay, this is minus, so here it's supposed to be minus. So this will give us rho v arrow plus delta arrow divided by minus open bracket rho v arrow divided by what? Delta arrow. Now we have this, then plus rho v arrow plus delta arrow divided by arrow. So we have this. So if we collect like terms, we are going to have this. So after getting this, the next step now is to take limit. Take limit. Now limit this one tends to 0 and delta arrow what? Tends to 0. Limit delta t tends to 0 and delta arrow approaches 0. If we do that, this will be delta t delta arrow tends to what? 0. So the next step now is to limit delta t and delta arrow tends to limit this to 0, limit this to what? To 0. So if we limit them to 0, if we limit this to 0 here, we are going to have partial phi rho divided by what? Partial t will be equal to, limit this one here to 0, we are going to have partial rho v divided by partial arrow, then plus rho v divided by arrow. Remember, it's not going to affect this since this one is not dividing change in arrow. So we're just going to have rho v divided by what? Arrow. So since we have this, this will give us the phi rho divided by dt will be equal to, now let's factor out 1 over r from this. If we factor out 1 all over r, we're going to have 1 all over r into r partial rho v divided by dr plus rho v. So if we factor out r, we are going to what? Have this particular equation. So this particular equation can also be written in this form: partial phi rho divided by rho t will be equal to 1 all over r will be written as dr rho v all over what? Dr. Now this expression, this last expression is gotten from product rule, such that if you differentiate what we have here, we are going to have this expression. So we got this expression from this expression. All right? If you differentiate this expression, we are going to have this expression. So this one is gotten from, this is the product rule expression of this particular one here. So this equation here becomes the continuity equation for radial flow. So this equation becomes the continuity equation for radial flow. Thank you.